let's explore LRU Cache, design and implementation in detail. Hello everyone. Welcome to our tutorial on LRU caching. Today we'll dive into the basics of LRU caching and explore its key concepts. Then we'll design an efficient LRU cache system before moving on to implement it in Python. We'll also look at a real-world example to see how this can be applied practically. Finally, I'll share with you what makes for a good versus a bad approach when implementing an LRU cache. Let's get started. Let's explore what is an LRU cache in detail. Let's explore LRU cache design in detail. Let's explore output of LRU cache implementation in detail. Let's explore real-world usage example in detail. Let's explore wrong versus right way in detail. Alright, let's dive into this quiz question. Imagine you're implementing an LRU, least recently used, cache but forget to use the class. What happens then? Well, if you do that, your cache won't maintain the order of access. This means when it comes time for eviction, removing the least recently used item, it will make a wrong decision. Essentially, the LRU functionality is compromised because without, the cache loses its ability to remember which items were accessed first and last. So, if you're counting on your cache to efficiently manage memory by keeping the most recent data handy, don't forget that plays a crucial role in making sure everything works as intended. Welcome back, everyone. Today we're diving into the best practices for implementing an LRU, least recently used cache. First up, let's talk about using. This is like a dictionary that remembers the order in which items were added, perfect for tracking when things are accessed or used. Next, if you're working with multiple threads accessing this cache, make sure to add thread safety measures. Otherwise, your application could run into some unexpected issues. Lastly, keep an eye on the capacity of your cache. It's a balancing act. Too small and you might miss out on performance gains. Too large and it can slow down your system. Regularly review and adjust this based on your app's needs. That's all for today. See you in the next tutorial. Welcome to our quiz on why we should prefer using a built-in LRU cache. Let's dive in. First, think about optimization. Built-in implementations are often tuned for performance, saving you from the headache of fine-tuning yourself. Secondly, consider thread safety. With built-ins, you don't need to worry about concurrency issues because they handle it for you. Lastly, using and maintaining these caches is a breeze. They come with all the necessary features out of the box, so your development process becomes much smoother. So, when working on projects that require caching mechanisms, leveraging these built-in LRU caches can save you time, effort, and potential bugs. Welcome back, tech enthusiasts. Today, we're diving into the key takeaways from our LRU cache design and implementation. First up, caching is a game changer for application performance. It's like having a super-fast memory bank that stores frequently accessed data, ensuring quick retrieval times. Like keeping your favorite playlist saved on your phone, so it loads instantly. Next, we designed an efficient LRU, least recently used cache using Pythons. Think of it as keeping only the most recently used items in your backpack, discarding the older ones. Lastly, we implemented real-world caching scenarios for API responses and database queries. Imagine fetching weather data or user profiles. By caching these, our app can serve them much faster, reducing load times and improving user experience. Happy coding!